Hi, here's Rolf. In this video I would like to discuss how a search engine works. I would like to focus on the three main components of a web search engine: the crawler, the indexer and the query processor. So the indexer is a piece of software that goes and fetches web pages in a systematic way, takes these web pages and hands over this web page to the indexer. The indexer looks into these web pages and tries to extract the most important words that occur in this web page and builds the so-called inverted index. The query processor then takes a user query and tries to answer this user query over this inverted index by using a Boolean search. I would also like to give you some background information how Boolean search works. And then the query processor comes back with a bunch of documents, and we have to be able to rank these documents somehow, because we would like to have the best document on top of the list and display this in the web browser. So why is search on the web a problem? We can see the web as a very large unstructured data store, and this is very different from a relational database where we have structured data and we have a nice query language like SQL that allows us to query our data, our structured data. But this is not the case in the web, where the data is unstructured and the amount of data is huge. There exists about 21 billion of web pages nowadays. But there is no central index for all these web pages. So the problem is that these web pages are changed, new web pages are created, web pages are deleted, and we have to deal here somehow with a moving target. So we need to have a mechanism to build such an index somehow dynamically and update this index all the time, so that we can do some search over this index. But the situation is really bad, because we don't even know where all the web servers are. So as with web pages, new web servers are created, come into existence, and web servers disappear. Yeah. So we have also to deal somehow with this situation. And web search engines allow us to deal with this kind of quite tricky situation, where we have to deal with unstructured data, where we have to deal with this kind of moving targets. Web search engines like Google, Yahoo and Bing can provide a solution for doing search. And also to some extent directories like Demos and Yahoo directories that allow us to build up a data store. And we have to do this frequently, and we have to maintain this data store somehow. So have you ever wondered why a search engine is so fast, given the fact, that we have this large amount of unstructured data out there, and how actually a search engine can find something and where the actual search happens? So let's quickly have a look at Google. Yeah. So let's first search here for a term. Let's search for comp 225. Yeah, let's say comp 225. So you see, when I search for this term comp 225 in Google, Google finds 9,760 results, so 9,760 documents. And you see, he ranks the document, Google ranks the document here, and I get here comp225, algorithm and data structure. And within this short time, Google is also able, to retrieve this snippet of text that is actually a part of the document that we are looking for. Let's now change this query a little bit. Yeah. Okay. Let's say comp225 and let's say Macquarie University Sydney. Yeah. So what I'm doing here, I make now my search query a bit more complex, and what I'm expecting here is that I can reduce the number of results. Yeah. So let's see what happens. Okay, I search here, and you see now I have 314 results, documents, and the time here goes a bit up. I have now 220 seconds it took Google to come up with these results. Still pretty fast. Let's see now what happens if I remove this expression here, Macquarie University, for my search. Okay, let's search again. What you see now, I have 9,760 results, but it took Google only 70 milliseconds to come up with the answer. So it seems that Google probably caches my previous search somewhere, yeah, and then takes simply the cached search, so that it can come up with in such a quick time with the result. So the thing is, we actually don't really know what Google is doing in the background. As these things, search, are usually company secrets, but we can, start guessing what they are doing. So let's first think about how actually such a search engine works. So a search engine basically consists of three main components: a crawler, an indexer, and a query processor. A crawler is very often also called a spider or a robot, and the task of such a crawler is to go and find and fetch web pages in a systematic way. So the crawler usually works offline. This means the crawler doesn't work at the same time while you are querying. Of course it works probably while you are querying, but this crawling is not related to the query process. Yeah. So the crawler fetches web pages and hands over these web pages to the indexer. And the indexer is a piece of software that tries to look at the web page and tries to extract the most important words from the web page and builds up a so-called inverted index. This is a data store that we will then use to query. And also the indexer works offline, in the sense it works probably also all the time, but not actually is not related when you query this kind of work. So crawling and indexing are going on offline, and the query process is actually the things that is going on online. So you query, and the search query is then sent to the indexer and is compared with information in the index, and the query processor comes back with some recommendation what documents are relevant ones. So you have three components: crawler, index, and the query process. So what you see here on the next slide basically shows you the first two steps, so the crawling and the indexing. So what we have a crawler or a web spider, and we start from a very, very prominent web page usually. Yeah? So let's think about probably a website at IBM, or website at I don't know, probably Microsoft or something like this. You take a very important web site, and you start from an important website, and then what you do, you take this the important web page first, look at the web page, and extract all the URLs from these web pages. And these URLs are your seed URLs, and then you go to also kind of web pages and retrieve these also web pages. So the job of the crawler is basically to retrieve web pages, look at the URLs in these web pages, and retrieve new web pages and hand over these web pages to the indexer. Yeah, and so a crawler can do this in different ways. Probably he can use a breadth first search or deep first search. Yeah, so different kind of search strategies that you can apply to this kind of crawling process. Okay, so the crawler takes a web page, retrieves it, and hands the web page over to the indexer. The indexer looks at the web page and uses some strategy to extract the most important terms in this web page and builds a so-called inverted index. What the indexer usually also does, it adds some weights to the words. Some words are probably more important than other words. And then what happens usually, as the data is usually encoded and represented in a compact way on a hard disk. Usually these indexes are distributed over many machines. Okay, and the question is then, how does the crawler actually work? The crawler uses URLs from very popular web pages as so-called seed URLs. So you use very popular web pages as a starting point. Then you visit the seed URLs and retrieve the pages, and you identify all the hypertext links in these pages and add them to the list of URLs that you have to visit next. And as I said, the different strategies how you can work through these different URLs. And then you retrieve the web pages and hand these web pages over to the indexer. And the indexer does its job, retrieves important words and builds up the inverted index. And the crawler continues visiting URLs according to a set of policies. So these policies are important because we want to do the crawling in a kind of a guided way, yeah. And there are some kind of a selection policies that a crawler follows. This selection policy defines which pages should be downloaded and which pages should not be downloaded. There are revisit policies that say when do we have to check again for a specific web page. Let's assume you have a website and you would like to have this website crawled more often than other websites where you don't have so many changes. So we have this revisit policy that says how often a website should be crawled. Then we have politeness policies that say don't overload the website. When you fetch these web pages from a website, do this not too fast, otherwise you overwhelm the website and the users cannot use the website anymore. And there's also parallelization policies that coordinate some kind of distributed web crawling, because these web crawlers are large pieces of software and they are crawling different websites at the same time, and you have to make sure that this is somehow coordinated, yeah, this process, so that you don't crawl the website. It uses the crawler to crawl the same website again and again at the same time. Okay, so Google's web crawler is called Googlebot, and in simplistic, probably here it's a bit simplistic ways, these Googlebot functions similar to your web browser. So Googlebot sends actually a request to a web server for a specific web page, downloads this entire page, and then hands off this web page to Google's indexer. But what it does, it extracts the URLs and find out where to go next. Yeah. So Googlebot consists of many computers that request and fetch thousands of different pages in parallel. And Googlebot has built in some delays for individual requests to avoid overwhelming web servers. Yeah. Okay. So it retrieves these web pages and gives these web pages to the indexer, and the indexer then has to extract the relevant words. So this is a bit an art to find out which words are relevant and which words are not relevant in a web page. So usually what the indexer does, it tries to extract content words and get rid of stop words. Stop words are also called function words, are words like the, every, some, and, or, if, then, and things like this. Yeah. So, and you can enumerate these words, so you can build a stop word list, and then you can filter out all stop function words or stop words from a web page, and what goes into the index are content words. So what you try to do, you try to build a so-called inverted index. So what you do, you have, for instance, here the word that you find on a web page, and then you store where this word has been found, in which web page. So let's imagine we have here COM249, and then we have here the URL that points to the web page where COM249 is found. This is the first web page, second web page, for instance, and the third web page. And here we have another term, for instance, COMP225, and the URL where this term is found, in which document. Yeah. So URL that points to the document. But additionally, what happens is that these terms here, these entries in inverted index, are usually augmented by weights. So we add weights and that tells how important a specific term is, yeah, related to other terms. So the question is really, when we build such an inverted index, what information do we want to keep? What information is important information? What information tells us actually something about the web page? So what happens is that we often remove stop words. Yeah? We build a stop word list and it removes these words when we build the index, like there, is, on, or, and so on. And what is also going on is that we try to normalize the information on the web page. So we ignore punctuation, multiple spaces, and we really only try to extract these important content words. And we want to really, what we want to get are the most important words that occur frequently on a web page and makes a web page somehow also distinct from other web pages. So what is important is where these words occur on a web page. So we have to ask ourselves, do they occur at the start of the page, towards the end of the page? Do they occur, are they embedded in specific tags when we use HTML? And we also, when we are at the beginning of a web page and look at the words, we can think about giving more weights to the words that occur at the beginning, for instance, first 50 and 100 words, because these words usually tell you more about the importance of the web page, or what the web page is about. So this is a bit an art, and this is a company secret, how are people who built this search engine builds this inverted index. So what seems to be very important are usually the information between the title tag. Yeah, so they try to extract the content words that is sitting between the title tag, that is part of the HTML header, and also between the headers, H1 to H6 headers. We try to extract the information that is sitting there. Another source of information that is important is the root domain name of a web page. So you have something like http keyword.com, then you try to extract the keyword. Yeah, you try to look into the URL and try to extract the information from the URL. Or another important source is actually the link that points to a web page. Let's imagine I have a web page and I have a link to Steve's web page, and as an indexer indexes Steve's web page, then we also look here at the URLs that I'm using to point to Steve's web page. So, and then I know this web page, the indexer knows this web page is about Steve Cassidy. What is also important is the information in anchor text links within a web page. So here we have external information that we take into the consideration, and here we have internal information that we take into consideration when we build up our index here. And usually, as you see here, the information is usually normalized. Everything goes into lowercase letters to improve performance. Yeah, when we build the inverted index. Of course, you can try to build such an inverted index. You take a Python's URL lib, you fetch a web page, and then you try to filter the web page, and you set up some kind of guidelines, what kind of words you would like to extract, and probably you might want to give some weights to these words when you build the index. So you can build an inverted index in many different ways. Probably a good idea is to use a hash table, and what this is here really a very, very simplistic way how we could do this. So what you see is here in Python, I build an index. I use basically a dictionary as my data structure. I try to extract from a web page terms and URLs, and then I build up for a term, a list of URLs. This is my inverted index. So then you can use this inverted index to do some search. So a prominent way to do this is to use Boolean search over this inverted index. So the key idea here is to convert Boolean operations into set operations and take advantage of the information that is stored in this inverted index. And then we return only pages that satisfy this Boolean query. What we need additionally is we need to take some care of an additional method that does the ranking of the pages, because Boolean querying by itself doesn't give you a ranking. It says only this query answers this kind of documents and retrieves a set of documents. Okay. So what you see here is an example. So I have here a number of documents, yeah, D1, D2, D3, D4, D5, and so on. And I would like to show you now how, give you an idea how Boolean queries work. Okay, so I have document 1, and this document consists of contains the word unit, COM225 exam. COM225 is in document D2, D3 contains these words. Yeah. So what I do first, I build a so-called inverted index. Yeah. So I say unit occurs in D1, D3, D4. This can be the document or simply URLs that points to the document. Yeah, COM225 occurs in D1, D2, and D3, and so on. So what I would like to do now, I would like to query my inverted index. So this is my data structure that I would like to query. So here's my query. I would like to ask is a unit and is either COM225 or COM249 and doesn't contain the word exam. So I would like to find such document that fulfill basically these constraints. Yeah, it must be a unit, and I'm looking for COM225 or COM249 and not for the word exam. So what we want to do, we want to in order to process this, we want to translate this into an equivalent set operation. So what we do, we map here this ampersand here into intersections or into union, and the not into difference operation. So what I get out of this, I translate this query into something like this. Yeah, because unit now stands for a number of documents, D1, D3, D4, D6, D7. Yeah, okay, same thing with COM225. So what I do, I have here this set of documents. I have intersection, I union, and difference. So first what I do, I calculate the union, and then I calculate the intersection, and then I calculate the difference, and I get a result D7. So this is the document D7 that answers basically my question. Yeah, okay, it doesn't contain the word exam, but it contains unit, and it contains COM225 or COM249. So this would be the document 7. Document 7, unit, COM249. Yeah, okay. So I could do this actually in Python. And here is a very simple example that shows you how we could do this. Yeah, we could replace unit here by a set of documents, D1, D3, D4, D6, D7. I've COM245, 225, sorry, and a set of documents. So what I do, I use here from sets, I import set, and I try to do my set operations here now in Python. So what I do first, I calculate. Let's go back. What I need to do first, I have to calculate the union between these sets of documents. Yeah, okay. So what I do here, I calculate the unit as a union of COM249 and COM225, and this gives me the result union here. Yeah, okay. And then the next thing what I do, I calculate the intersection. I take result union, my results that I've calculated, and I calculate the intersection with unit, this set of documents, and this gives me result intersection. Then what I do, I calculate the difference. I take exam and I calculate the difference, and this gives me my final result here. So basically what I do here, I do the same things that I've done here. First I calculate the union, I calculate the intersection, and then I calculate the difference. Yeah, okay. And this gives me, here is a set that consists of one document. Okay, so but you might say, okay, but my favorite search engine doesn't use Boolean search, or does it? So if you have a look at advanced search, for instance in Google, you find out quickly that this search engine must work with a Boolean search, must use Boolean search. So in Google, for instance, each search term has an implicit AND operator. So each search term is connected with other search terms via an implicit AND operator. Yeah, and Google provides also Boolean operators. For instance, you can use the OR operator, so you can ask for something like Swans 2004 or 2005, and this gives you results with at least one of the terms adjacent here to OR. Yeah, 2005 or Swans 2004. Or what you can do, you can use this hyphen operator. This is basically a logical negation, yeah, a not. So you can search for antivirus, not software. So this should only give you the documents that come probably out of the medical domain. Okay. So there are also operators that you can use in Google. For instance, you can do phrase search. You can use these quotes, and then you can search for an exact phrase. You can also use as a wildcard operator, these asterisks, yeah, when you do search. Or you can do specific search for in specific sites. You use the site operator, and you specify a URL, and then you search over a specific website, for instance Macquarie University. Or you can specify a precise words that should match by using this plus operator. Play a little bit around with this kind of operators and do a bit use a bit Google's advanced search to get a feeling how this Boolean search works. So now we get a number of documents back, yeah, and we need to be able somehow to rank these documents. I said Boolean search by itself doesn't give you a kind of a ranking. Yeah, it simply tells you if these search terms are contained in the document or not. So for the ranking, Google, for instance, relies on the democratic nature of the web, and it looks at the links to your web page. So a link from a page A to a page B counts like a vote by A for B. Yeah. So if you maintain a very important website and link to my website, then my website becomes more important. Yeah. So Google analyzes a page that casts a vote for a page. So votes from pages that are important weigh then more heavily. So and these votes help to make also pages important. So this is one factor that Google takes into consideration for deciding about the relevance and do the page ranking. But there are actually over 200 factors that Google takes into consideration for doing the page ranking. And pages have to be both important and relevant for the search. The important thing here is that it's very difficult to find out actually how Google does the ranking, because these are company secrets. Because if you could optimize to try to optimize your web page, But it seems that what is very important is that you have a title, yeah, in your HTML page, and you use say informative information at the beginning of your web page. I have uploaded 2 videos that speak a bit about search engine optimization and also about how you can do personalized search. Have a look at these also 2 videos. And let me summarize what I have told you in this video. I've tried to explain what the main components of search engines are. We have a web crawler that fetches web pages in some kind of in a principled way, and we have an indexer that takes these web pages, try to extract the most important words. It builds an inverted index that builds our data store for doing a Boolean search. What we need then additionally to Boolean search, we need a kind of a mechanism that tries to rank the web pages. Yeah, and I have shown you that I've shown you that at least Google uses Boolean search operators. So you can use these Boolean search operators and do advanced search in Google to narrow down or to widen the search results. There are also a number of specific operators like these asterisks, or you can use quotes for doing a phrase search. But the important thing is these algorithms, in particular the ranking algorithms, are really company secrets. And you have to listen very carefully what these guys at Google say sometimes, to find a little bit out how they are doing this stuff. Okay, thanks for listening, and have a look at also 2 videos that I did upload.